This was a tricky one. It's the math guy, Steve. Evaluate the integral of 14 over 14 plus e to the x dx. So I'm actually going to use a u sub here. Okay, so let u equal e to the x. Then, of course, du is e to the x dx, which means du is u dx. So dx we can write as du over u. How does this help us? Well, then our integral becomes 14 over 14 plus u times du over u. Or in other words, we get the integral of 14 over 14 plus u times u du. And now we can use partial fraction decomposition. So in our partial fractions, we write this as a over u plus b over 14 plus u. Cross multiplying, we get 14 equals a times 14 plus u plus b times u. Since it's supposed to be true for every value u, then we can choose convenient values for u to plug in. Meaning, if I plug in u equals negative 14. This gets rid of the a term. And we get 14 equals negative 14b, so b has to equal -1. Or if I plug in u equals 0, that gets rid of the b term. So we get 14a equals 14, meaning a has to equal 1. So we can rewrite this as the integral of 1 over u plus -1 over 14 plus u du. Of course, those are a lot easier integrals to integrate, right? So we get the ln of absolute value of u minus the ln of absolute value of 14 plus u. Now they're done integrating, don't forget the plus c. Now we back substitute, u was e to the x, so we get the ln of absolute value of e to the x minus the ln of absolute value of 14 plus e to the x. Don't forget the plus c, or we can even simplify that because the ln of e to the x is just x. So x minus the ln of absolute value of 14 plus e to the x plus c. Always remember, math is everywhere.